Hello and servus from Bavaria. Welcome to our webcast, also known as mCast. If you haven't subscribed to our YouTube channel, you are strongly recommended to do so here and now. My name is Stephan Kehry. I'm the responsible product manager for textile goods, and in this respect, I want to tell you today something about how to straighten knitted goods. Let's jump right in. Knitted goods. We have them all around, we know them very well, and we also know that they're sometimes quite delicate. So, what do we have to do to straighten them, and what is nice to have? Those are the points that I want to discuss with you today. Let's first introduce the knitted goods, then go into the spirality that comes along with them, and finally end up with the elongation and the synchronization with all the devices which are coming afterwards. But before we jump into the subject, I have, as always, a small question for you. Think about your production. Do you have any issues with elongation so far? Please, if you have so, tell us more about it in the comments. But back to the subject. The introduction. Knitted goods are quite easy to produce. All you need is a knitting machine, and they don't require a lot of space, they don't require a lot of investments, so they're quite popular to have. However, they are calculated in weight instead of the length, which is the normal thing with the woven goods. So you have to consider some points, because elongation is absolutely no-go. Therefore, you have to handle them with a lot of tender love and care. And we tell you how to straighten them afterwards to make sure that the result is absolutely perfect. So, those are knitting machines, those are dyeing machines. The knitting machines during the production are actually producing a picture of the fabric like that. So it's quite straight, it's quite harmonic, it's quite synchronized. However, when it comes to those dyeing machines, we are always talking about different tension, different operators, different machines. So the distance between the transportation of the fabric and the water bath, the amount of water, the handling of the goods are so different that you will find an elongation during the process. So from here to there is a huge difference, and this elongation also varies from batch to batch due to all the different issues, because they are not synchronized in the way that you have it normally with the continuous process of woven goods. So those are factors that you have to take into consideration when you want to fix all the problems that have been brought into the product beforehand. So those are the issues that we have to deal with. We have some spirality, which plays a major impact for the detection. We have the tension control. Tension is a major thing. Just remember, we are measuring in weight and not in length, so it has to be rather compact than long, because the more fabric you have, the more money you get. Driven rollers are very important, and in order to keep it very compact, you have to apply as little tension as possible. So those are the points that we will raise during those 10 to 15 minutes today. The spirality of the knit goods results in sometimes really severe changes of the distortion. And therefore it's very, very important what kind of detection, what kind of sensors you bring into the system. We have two different sensor application at Mahlo. We have them both. We are the only producer, by the way, who is having both the systems. The first is a traversing system where you have a frame and you have only one sensor which is moving from one side to the other, and it is actually only detecting those points from one side to the other. It takes a certain time to start from left to go to right. It slows down at the edges, so the amount of information that you gain during that process is only very limited. And then you have the traditional way with multi-sensor applications. Here you have 6 sensors. With smaller applications we only have 4. With a wider width we can have up to 8 sensors, and those sensors, they continuously measure much more points in a row, and especially if you have a change in the distortion, like it is happening with knitted goods quite often, you have to make sure that you have that application, that you have a multi-sensor application to really make sure that you don't lose out on that distortion. So in this case, you have a constant online detection in real time all over the fabric from one side to the other, and you don't miss out on any severe change of the distortion due to only having one sensor which is traversing. So this is coming along with the spirality. And then, as I said, the tension control. It's very important that we keep the tension as low as possible. And therefore, we do have a pendulum compensator at the end, which is synchronizing actually the drive from the next machine with the drive of the previous machine. And what our tension control does is that it is driving the rollers, the bow rollers, accordingly to take the tension away from the fabric. So it supports the transportation of the fabric, of the knitted goods in a very positive way, to leave those goods with as little tension and as little damage as possible. So this is the one thing. The other thing is the bow rollers as such. In order to minimize the tension, you have to know that the bow rollers are applying tension. Every part that we have to straighten the fabric with an active straightener, like a roller straightener, is applying tension to the fabric. So the amount of bow rollers is really playing a major role. If you have too many bow rollers, just because the standard is asking for 3 bow rollers, you apply too much tension to the fabric. What you should do is really look for the detection and the bow and the situation of the fabric before correcting it, and then calculate the amount of bow rollers individually. And that is what we do. We do have the experience and we do have all the tables to identify the need of the amount of bow rollers. And only by doing so, you can really optimize the tension with those bow rollers. The other thing is those spreader rollers. These knitted goods, they have a very, very bad thing. They are dwelling at the edges when you pull the fabric. To avoid that pulling, to avoid that dwelling at the edges, we normally have spreader rollers. And those spreader rollers, they make the fabric even on both sides. However, also at those spreader rollers, you apply tension. And again, here you have to optimize the process by just adjusting the wrap angle. And this is why we at Mahlo, we have an adjustable wrap angle for those spreader rollers. That means for you that you only apply so much tension and so much impact into the fabric as necessary. Again, you optimize, you minimize the tension where it's needed and where you can minimize it. Another thing we definitely have to talk about is the elongation of the fabric. We want to prevent that elongation, and that means that we have to look into the density of the fabric. So, talking about looking into the density, we have a special sensor that takes over that role. We have that sensor over here before the stander, and we have another sensor at the exit of the stander. Those two sensors have different purposes. So that little fellow in the entry is telling the overfeed roller to run either faster or slower. If it runs slower, of course, it is bulking the fabric. To run faster, it means that it's actually taking away some fabric from the stander. And by measuring that density at the exit, we can give a very, very good indication about the weight already of the fabric when it's processed through the stander. Let's just look into it and show you a little example. So if we have a fabric with 20 picks per centimeter at the entry, and we have an overfeed roller running with 25%, that results in a total pick per centimeter of 25 picks. So if, for example, we have only 18 picks and we still want to result in the same amount, we cannot run with 25 because then we only would achieve 22.5 picks per centimeter. So we have to change something. We have to just bring the overfeed roller up to 27%. So that runs then with different speed, and with this different speed it will again have the right amount of picks per centimeter. And the sensor that we have at the exit will define that result also for everybody who's interested in what you are doing in the production. So these 25%, the target will be directly then shown at the exit and will give you the peace of mind that you have done everything right, and all those systems are running automatically. That means it's a closed loop system which doesn't need any human interference. So, the summary. The knits are very easy and cheap to produce. However, you have to make sure that you do a lot of things in the right way. Due to the delicate structure, you have to look into the elongation, you have to look into the spirality, you have to look into the connection, the interfaces to all the other corresponding machines. And with all those things in place, and of course with the Mahlo system, you can make sure that at the end of the day, even with knitted goods and even with all the differences in the spirality, in the elongation and in the structure of the fabric, you will end up with a very, very good and satisfying result. If, for what reason ever, you have not subscribed yet to our YouTube channel, you can do that here. Of course, on our website is always a brand new variety of different documents, white papers and other things that you can check out. You can also drop me a mail and then I will send you the presentation directly. And yeah, if you liked it, then just leave me a comment. So far, thank you so much for your time. Thank you, and all the best for the future.